Discover Next, the studio for facades and design. Next is the platform for innovation in the field of building envelopes, for inspiration, information, and communication. Initiated by Vicona, with leading industry experts as Next partners. Next is a unique concept which is constantly evolving and bringing the future of cities to life.
Guten Tag, good evening, Salam alaikum, and wish you a very, very good evening. My name is Arvind. I'm the Communication Manager for Hydro Building Systems Middle East, and welcome to the 6th Next International Facade Summit. So let's give a big round of applause for all of you for being here on time. Yeah. And for people who are joining the summit for the first time, just a little bit of background. Over the last 5 editions, we have touched more than thousands of delegates from 46 countries with more than 20 international reputed speakers who are architects, facade planners, engineers, investors, and so on and so forth. Today is a very special day because it's a hybrid event, the 6th edition, and we are blessed to have a fantastic set of speakers from Dubai, Copenhagen, to Munich, and Spain. What's very exciting also is where we are streaming this event from. This is the Next studio, the heart of Frankfurt, the heart of Germany, in fact. And here we are present in an environment which has not only Vicona, but also our partners demonstrating some of the finest technologies in windows, doors, facade, and building envelope solutions. So, welcome once again for all of you present here and for the audience who are present online. Without further ado, I want to invite our first speaker for the day, a very dear friend who has come all the way from Dubai. He's a facade professional for over 20 years with projects around the world, holding long-term positions in Stuttgart, London, New York, and Dubai. And after building up the office in Dubai for Werner Sabeck in the position of Executive Vice President, he is now managing a wide range of interesting projects all across the Middle East and in Europe. Apart from being a well-known facade planner in our region, he is also a great adventure seeker. He's a great motorbiker, and he once drove his bike all the way from Germany to Dubai. Ladies and gentlemen, please help me welcome Benjamin Beer. The floor is yours.
So thanks, Arvind. Many thanks. Yeah, warm welcome here from the stage in Frankfurt at the Next Studios. I'm very happy being over here. I'm very happy that we are such a nice audience over here, locally in Frankfurt, but also globally. We are the people who watch this actually online. Now, I was asked, what do I want to present today at this Next Summit? And people talk about certain things right now. It's about the crisis and war and so on. But I think we want to focus on certain things. It's about think globally, build locally. And it's also the whole topic, what we see right now is actually sustainability. And currently everybody does talk about sustainability, but I want to get a bit deeper into the kind of details. So what is sustainability? How can we push it further? And what is the kind of future of the kind of facade systems? I would like to start my presentation with this nice photo over here. Now, talking about green buildings. This building is so green, you cannot see it anymore behind a green landscape. Is this the future or is this the past? Yeah. Are we smart what we do today, or have the people in the past been smart? Yeah. I would like to question certain things. You know, this building was built in the 16th century. It's like 400 years old. So this building survived 400 years and is still in the same stage as it is now. Now, looking to the kind of specifications, you know, I'm a facade consultant. I'm working for Werner Sabeck. We are consultants having offices worldwide, doing structural engineering and also facade consultants, what I'm doing. Now, looking at the specification of this 400-year-old facade system, and now look at this. It's a double-skin windows, operable natural ventilation. We have operable external shading. You can open and close this kind of flaps. We have operable internal shading by the blinds. We have adjustable U value. You open 1 or 2 windows. What else do we have? We have low maintenance. Environmentally responsive, it's all timber. Full recyclability, it's just single layers of glass. And it's biodegradable in terms of the kind of wood. Okay, let's take the paint off. And this survived for 400 years. Now our facade systems that we're planning today, are they going to survive 400 years? Insulating glass units with silicon, butyl seal, spacer bar, with desiccant. They're not going to survive this time. So it's a bit of a question, what are we doing nowadays? I'm talking about sustainability. These buildings, back in the days, 400 years ago, were like CO2 neutral. They've been smart. They had a kind of barn. So all of the animals, like the cows and chickens and whatever they had, or pigs, they would, actually, they put it in the ground floor. So if you look over here, so the barn was just over here. The warm air, it goes up, and I just had a kind of wooden floor, so the warm air was going from the barn into the living rooms. Then they had one central stove, so one central fireplace over here. And they put all of the rooms around this one single place. So in the past, also the people have been smart. They've been working with whatever they had, both in the cold climates, but also in the hot climates. Also look in the Middle East, this is like Dubai. People built wind towers. It was not about the kind of cold, it was about the heat. How can we protect ourselves from the heat, or how can we create a more comfortable thermal environment? It's about human thermal comfort. So these people in the past, they didn't have air conditioning, so they built these wind towers. And later I'm going to show you one of our projects where we more or less copied or use a similar thing of collecting wind and collect it down for a higher thermal comfort of the people. Now, also these were built like hundreds and hundreds of years ago. Also, these kind of buildings were CO2 neutral. Of course, they didn't have AC and they didn't need a fireplace. They had so-called mashrabiyah windows in the hot climates. So they actually provided shading, they provided privacy, but they let the air passing through. And you know, I've been presenting this at a conference in Saudi Arabia, and people stood up, oh, gentlemen, yeah, in the past everything was better, we're living without air conditioning, people were less sick, having no colds. But actually, how does it work? I think we need to understand why we're doing these things. It's about our human being thermal comfort, how we feel comfortable, yeah? And the United States, or the Army of the United States, in 1943, a kind of experiment, they put human beings in a climate chamber, in a climate box, and locked them in. And they started, you can see, this is a kind of temperature over here, and the days of exposure, yeah? The top is the heart rate, the bottom is the skin temperature. And you know, when people are put into an unpleasant environment in terms of temperature or humidity or combination of both, your heart rate goes up and your skin temperature goes up, so you're feeling uncomfortable. But this curve is going down. So after about 6 to 8 days of exposure, you start feeling comfortable. Yeah? It's the same when you fly to Spain for the holidays. The first, oh, it's so hot over here, and after a couple of days, you acclimatize. Yeah? So we as a human being, we can acclimatize to different climates. But nowadays, we're no longer willing to do it. We want to put the AC up and down in our car and so on. So sustainability starts with the understanding of us as a human being. Because in the end, we're building buildings for human beings. Yeah? And this is what the past is. So that this is a kind of mashrabiyah to get some airflow getting in through there. So it's about the past, what people did in the past. Now, we're now transforming some things from the past into the present, and maybe also into the future. This is one of our current projects in KSA. Now, currently, Saudi Arabia is booming. There are a lot of developments over there, and we're getting questions, how can we create a more comfortable outdoor environment so that people can walk along and feel like in Italy, yeah? Have a coffee, have a bit of gelato or ice cream, whatever. So it's about two things, about shading and also providing higher thermal comfort in terms of airflow. You know, when people stand, airflow is bringing your thermal comfort up in a hot climate. So the whole idea, for example, with this project was to link the buildings. So it's a kind of big kind of development, and we're building a big central spine, we call it, where we're, and along this kind of central spine, people can then walk along, get shading. And we also put in these so-called wind towers. You can see this kind of things that actually stick out. So and nowadays, we know the main wind direction, so we know where's the wind coming from. So we start collecting this wind and then driving this wind in the wind towers down into street level. So we're trying to achieve high thermal comfort for the people around there. Now, this canopy, it's about up to 60-meter clear structural span, this kind of good show structure. We put the wind towers. Now, the wind towers, they have certain flaps inside. I'm going to show you later on how the design works. But you know, it's about thinking, how can we get this, first of all, designed, in terms of doing CFD analysis, all of these studies, analysis, and so on, and then getting it built, meaning doing actually structural calculations, optimizing the geometry. And for example, this is on the top left, is the so-called grasshopper script. So we're doing a parametric scripting because these kind of complex free-form shaped geometries, you can only handle them actually parametrically. We can then see over here the kind of different sections through the canopy. And this is also a thing what I try to explain to, for example, to young structural engineers. The starting point is our brain. Yeah. So all of these tools that we have in terms of structural engineering or in terms of parametric modeling and Rhino, Grasshopper, and so on, it starts with the question, what do you want to achieve? Yeah. So the software only gives you an answer, but you need to know the question. Don't expect the software to give you both the question and the answer. It doesn't work. So we start with relatively simple geometry optimization. Yeah. In the end, structural efficiency is about arches. So we're building arches like the Romans did, like in Rome, like the Pantheon in Rome, built like 2,000 years ago, a big arch. Ideal shape. We do similar things nowadays. And this thing is not what the software will tell you. The software can optimize things later on. So this shows a couple of slides on the geometry optimization, getting the grid shell. There was another consultancy called actually RWDI doing CFD analysis. And this shows a bit how we pick up the wind at the top. Now our wind tower at the top has a rotating drum. So based on the wind direction, I mean, we know the two main wind directions. We can rotate the drum and then collect more wind. And you can see here how the airflow goes at the bottom and then into the central spine. You can see here the kind of blue areas over there. It shows areas where the thermal comfort of the people walking along there is significantly increased without any mechanical means of cooling it down, the air. So quite nice things, but the complexity starts, how can we realize it? And you see a bit of here, it's a complex steel structure, complex cladding. The maintenance need to get in there, there are mechanical parts, there are a lot of components and so on. We're building a kind of mega scale elements to improve the microclimate in the city. Yeah. And with these things, you can see a bit over here, of course, people did ask, what about the times when there's no wind? And totally agree, there are times with no wind. So we then integrated a kind of fan system, having mechanically driven air with silencers to then blow the air artificially down by mechanical means. Of course, this takes energy, I totally agree, but this is the way how we actually did it. We then have a so-called misting system. So the misting system, it sprays a kind of dust or kind of water dust into the air to cool the air down, so actually evaporative cooling. And this is running like almost 24/7 in this kind of system. It shows a bit, the kind of complexity of things. All of the shading is realized by kind of sails, by kind of fabric sails in a larger scale, or pre-stressed. A couple of nodal points, relatively traditional steel grid shell with box sections and CNC machined nodal points, relatively standard, but in a big scale. Let's put it this way. Some more images showing the kind of system. And you see the complexity. This is kind of custom design. This is what nobody did actually before. So we're taking the requirements from the client. Okay, this is the thermal comfort we want to achieve, and then we are providing the technical solution for this. It's a bit of similar outdoor thermal climate and outdoor thermal comfort. This is one of our build projects. So the Expo 2020 in Dubai. So where's Werner Sobek? We were the lead consultant, the architect, the structural engineer, facade engineer, also the site engineer for all of these shades, sunshades. And this is so-called active system, so it can be open and closed, this kind of operable shading system. This system itself, you can see here quite a couple of nice photos, realized with an Italian fabric product. If you look in the next slide, you're going to see a plan view, and this is a kind of scale. So we're talking about almost kilometers of length of shading, external shading. Because in the Middle East, it's hot, people want to have shading, and this is what we did over here. There are 3 different types of shades, and there's going to be a video a bit of later on explaining what the kind of background was. And I hope that this is going to work now.
That we have to reduce dramatically the emissions. The announcement is to reduce CO2, greenhouse gas emissions, within 10 years by 55%, which is something different to save 55% of energy consumption. This is even more difficult to be achieved. Everyone underwrites that, but nobody really makes clear to himself what that means, because if we are not capable to change the technologies we use to produce the materials, to build the buildings, to run the buildings and to demolish them, if we are not, then in 10 years we are allowed to build only 45% of the amount we are actually building. Means half of us is becoming unemployed. Standing in front of a problem which says, okay, either you change everything or you cannot build in the way you build nowadays, will urge this interdisciplinary process that people start talking to each other and say, either we invent something or we are lost.
Okay, so this was Werner Sobek talking about the project and the membrane. And I'm going to show you a couple of slides later on what we have in mind in terms of the future. Now, membranes are lightweight. In this application, we use the membrane as an external shading system. We also nowadays want to bring membranes into the vertical facade systems. I mean, what we see right now, we see glass, solid panels, aluminum panels, and so on. But what's the future? It's always for us, we need to ask, how can we make things better? And also in terms of sustainability, more lightweight systems. So finishing with the expo in Dubai, a couple of slides. What's nice to see is about efficiency, is also efficiency in terms of structural engineering and also material saving. So the best sustainability approach is that we use material that we don't need, or we take it away. Now over here you can see that this membrane have a certain pattern. And it's not only architectural design intent, it's actually by the stresses, by the main direction of the forces within the membrane. So we orientate these kind of main strands, or the glass fibers within the membrane, in an orientation where the maximum stresses occur. And it's a bit of similar what a human bone is doing. Yeah? Our human body gives us sometimes the example how we can approach these things. And our bones are quite lightweight for the strength that they have. And they've orientated certain fibers in the direction of the maximum stresses. And the same what we have started doing with the membranes. Yeah? So it's about doing kind of smart things, of course. There's a lot of mechanical parts also. This is what we also take on as a consultant, as a complete challenge. We say we do the design for the membranes, but also for all of these mechanical parts, which need to be tested and proven with the chain-driven, the motors, and so on and so on. This is the final system, how it opens and closes. Now this project itself, it got a lot of awards to improve the exterior thermal comfort of the people over there. It's really a nice example. But moving on, using membranes, and I mentioned before that we want to use membranes, and this is the kind of thing, you know, we have either opaque, transparent, or translucent materials. Now, our facades always have to have a certain light transmittance, because the people in the building want to have light. This can be achieved either by glass, by transparent elements, or by translucent elements. So this is ThyssenKrupp Test Tower in Rottweil, one of the biggest membrane projects did in the vertical orientation so far. It's a kind of cladding of a kind of an elevated test tower. So there are no human beings really inside, but it shows a kind of large-scale application. And you know what, this is a kind of thing, so we started thinking kind of mono cladding. Yeah? So we're providing a rain shelter for secondary skin. So the outer skin of the facade doesn't have to be a piece of glass. It has to be, we could think about something more lightweight, translucent, letting air through, letting light through. And there's also currently a research project at the ELEC, at the University of Stuttgart that we collaborate with, that we're also using kind of fabric, a kind of fiber facade, that we're using fibers to collect rainwater, and also using fibers to get evaporative cooling. So a bit of thinking about the next kind of steps. This is test off from a certain distance. Now this is a current research project. So when we say about sustainability in vertical facade systems, we can say, okay, our facade is fully airtight and it separates the exterior from the interior, and we close the window and it's fully airtight. What if we say that our facade is permeable? It is translucent and permeable. Permeable means we're doing a kind of microfiber kind of mesh where we collect and harvest rainwater. And in case it is too hot, we use water to cool the environment down. Yeah? On the left, you see a photo of a water drop hitting a glass surface, and it explodes away. And this is what currently our facades, when rainwater hits the facades, it's going to explode and it goes down. On the left is a kind of a microfiber mesh, and the kind of raindrop hits this kind of mesh and getting kind of exploded in small elements. You can see it's a kind of water dust that we get over there. Now, these kind of things give the kind of idea. We're using kind of micro mesh, very small fibers. And these very small fibers are either able to collect rainwater, and we collect in certain drain channels, but at the same time, we're trying to enhance the microclimate in cities. Due to the global warming, our cities are getting warmer and warmer. How can we cool our cities down? One thing is, of course, to plant trees, greenery, but not often we have the space. I'll show you some project later on where we do this. But the idea is that we then collect the rainwater during the cold times, rainy times. And then during the hot days of the summer, we're spraying this rainwater on top of these microfiber meshes, and they evaporate with the natural airflow through this mesh to the interior. This is a test tower by the ELEC in Stuttgart. You can see this is a kind of setup over here. It's called a hydroactive lightweight facade system for urban climate. And the idea is that we are cooling a microclimate down in the city. So this is currently getting tested, and some results over here. You can see here, this is a kind of elevation of the wet state and the dry state. So the wet state means that we're spraying water into this kind of microfiber mesh from the top. Then we have natural airflow through this mesh. You can see here by the colors, we get a temperature drop of 10 degrees Celsius. Yeah? So the air is getting cooled down by 10 degrees just by the means of water and natural airflow. No air conditioning, no compressor, nothing at all. You can see here, this is a kind of temperature. This is the system being switched off. Then we spray water, and it drops about 10 degrees Celsius down. Of course, the humidity level is slightly increased, but we see this as a big future. Maybe in the future, we're not going to have a kind of very strict separation between glass, aluminum panel. We do something more lightweight, translucent, yeah, open kind of meshes. It also comes me to the understanding of the human being. And this is the thing what I'm very keen that we look into these kind of things. I'm currently working together with one glass supplier on the transmittance through glass. You know, every piece of glass that we're using nowadays, it has a certain coating on it, so-called low-E coating. So the transmitted spectrum through the glass that comes from the sun, it's a certain filtered spectrum. And this is the kind of thing about human beings and light. Yeah? These are two kind of submarine soldiers from the 1940s. And even back in the days, people knew that human beings need light. Yeah, so they got out of the submarine into kind of light, so they put them into lights to get them more happy. And this is kind of thing because even after COVID now, people are getting more depressive. Yeah? This is a map of the United States showing depression and anxiety. And you can see what's really nice to see is that all of the so-called sunshine states like California, Texas, they have a low percentage of depressive people. At the same time, they have the highest amount of natural sunlight. So there's a clear correlation between sunlight and human well-being in terms of mental health. What does it bring us to? I mean, we're the human being. We became an indoor species. We spent most of our time indoor. So this American study, about 87% of our time was spending indoor, inside rooms. Yeah? So we're getting our light from light bulbs and through glass. This is where we get our light from. So we spend only 6% in vehicles and about only 7% outdoor. And this you can see, this is a kind of two graphs where then the facade engineering comes into play. We get our light through glass. Of course, this is then light bulbs, this is another thing. And I'm going to go through these slides relatively quickly. It's about human well-being. This was the past. Lots of artificial light. People found out this caused the so-called sick building syndrome. People were getting sick because of the lack of natural daylight. These are a couple of new things where we currently researching into. It's about how the human being behaves under certain light conditions and what kind of glazing do we need for the future. So what kind of glass selection, what kind of coating on the glass do we need as a balance between sustainable building design and human-centric design? Yeah? And this is, for example, a traditional candle. This is the emittance. So what kind of spectrum does a candle emit? And it's a lot of the long-wave radiant heat, so the long-wave red spectrum, so radiant heat. Then we got the kind of normal light bulb, and we get a peak over here about 1,000 nanometer wavelength. In principle, what's important to know that we as a human being, our eyes can see the solar spectrum between 380 nanometer wavelength and about 780. So this is what we can see. I mean, we call it so-called visible spectrum of the light. And nowadays, for example, the LED light bulbs that we also have over here, they do not emit anything above 780 nanometer wavelength. And this is where the energy efficiency comes from. Yeah? But this also means that in the past, while we as a human being have been exposed to all of the spectrum, all of the wavelength, nowadays it's gone with the LED lights. If you now start looking into the light and human being, I'm going to go to the glass later on. This is a penetration depth, or the penetration depth, how deep certain solar radiation, certain spectrum goes into the human skin. And you can see that the penetration depth, it starts at about 800 nanometer wavelength. Yeah? That's exactly the wavelength that the LED lights no longer do no longer emit, and that most of our glass coatings do no longer transmit. Yeah? And going through this then to the glazing, to our glass, what we install. So in the past, we just had single glazing, or people just outdoor. And for the outer people, you're exposed to the full spectrum of the sunlight, the complete wavelength, starting from the ultraviolet blue to the visible spectrum and the infrared. Then the so-called single silver and double silver solar control coatings, which go further down, they started to being solar more selective. And what we have nowadays, I think this is on the next slide, correct, this is here, the latest state of our low E solar control coatings, they no longer transmit any kind of spectrum above 780 nanometer wavelength. So the whole infrared spectrum is gone. Yeah? So we're doing certain things to us as human beings. And we human beings, we have been on this planet since millions of years. Yeah? And now just over the last 10, 20, 30 years, we're starting experimenting with us as a human being in terms of exposure to a certain wavelength, which is no longer existent because of energy saving. I'm not against energy saving, but it's. I just want to show you, for example, all of your mobile phones, your iPhones, Android, whatever you have, Samsung, they have this night mode. Yeah? So your night mode takes away certain blue spectrum of the light. Yeah? And this is important for a so-called circadian rhythm. So talking about the kind of wavelength, for example, this is a new medical approach against Parkinson's disease. And this is the red light spectrum that our LED lights no longer emit, our glass is no longer transmitting. So a couple of things, infrared, I'm going to go through this relatively quickly. I would like to focus on the blue spectrum. Yeah? It looks a bit medical, what I'm talking about. In the end, it's all about our facade systems. We need to go to the kind of long way and then close the circle and come back to us as a human being and what we need to design. For example, jaundice. Newborn babies have a problem with jaundice. It means that the lever of the baby is no longer, or it's not yet capable to clean the blood. They're getting exposed to blue light about 460 nanometer wavelength, so that the skin is doing certain function that the lever of the baby cannot do yet. Yeah? So it shows a bit how important it is that we look at certain, for example, the glass selection and how the glass selection will evolve in the future. Now, I was talking about your mobile phones, yeah, and the night mode or the kind of comfort lights that you switch on. It's usually taking out the blue light, yeah, and it's usually in the afternoon when we're going to go sleep. And there's been some medical, even the Nobel Prize awarded for this. So for the circadian rhythm, this circadian rhythm, this dictates your day and night kind of rhythm of human beings, which means in the morning hours and lunchtime, you need the blue light. But after lunchtime, you should get less blue light exposure, otherwise you're not falling asleep. This is why all of your mobile phones have this mode, this night mode, because it filters out the blue light. It's getting more kind of yellowish. Yeah? And this is a question, why is this important? For example, when we select glass, we have the so-called visible light transmittance of glass. And this shows how much natural daylight in the visual spectrum the glass is actually transmitting. Now we have the so-called, which is new, we call it the so-called melanopic transmittance of glass. So we look at glass not only at the visible light transmittance, we're looking at the melanopic transmittance in the blue light spectrum that's important for us as a human being. Yeah? And this is the kind of thing where we say we have to be smart, we need to understand what the human being needs. Yeah? It's not only looking at the shading, G value, it's about refocusing on us as a human being. And quite often it's not this important, it's not this complicated. Yeah? Let's put it this way. This also then comes into certain things. What kind of colors are we using in our room? Yeah, I think a lot of kind of from architects over here. It's about it's a so-called spectral reflectance of certain colors. And is the blue light spectrum reflected by these interior colors? A lot of interesting research that in the end, I think in the long run, will also change how we design buildings, so the interior design will be done. It's all about this kind of refocusing on the human beings. Now, talking about 480 nanometer wavelength, what color is it? It's a blue. It's roughly this kind of bright blue. Yeah, then going into dark blue and going to the green. So this is the color that we kind of prefer as a human being. And this is exactly the colors. If you look out of your windows, you want to see a blue sky, a bright blue sky, and some green, and some fresh green, not the dark green. And if you look over here, into the property market, how does it translate back into the real life? All of these apartments around Central Park, you pay a premium. Park View is like double the price. So people want to see the green, yeah, and people also want to see the blue. And this also comes back to the understanding of what we need as a human being. So what can we do? Talking about parks, for example, this is like Central Park. This is one of our recent projects. I think this is one of the largest kind of green buildings, but true green, living green buildings. It's Kühlbogen 2 here in Germany, Düsseldorf. In the end, the building became a park. Yeah? So we are building a facade system that's completely green. Now, it's not only one thing. I mean, people say, oh, why do you do it? For example, if you now say all of the adjacent buildings, for example, people here on the other side, they're not looking in the gray facade of a neighbor, they're looking into greenery. So what you can see that the surrounding buildings, the value goes up because the people get a park view. Yeah? So what's the future? I mean, in the end, are all of our buildings going to look like this? I don't think so. But we have certain issues that we have to tackle. Our cities are getting more and more warm. We have global warming. And we need to cool our cities down. And why not in this kind of way? So Kühlbogen 2 going to go a bit into this kind of thing. We're talking about the living facade. It's a lot of collaboration between the designers, facade engineers, and also botanical people. So what kind of plants do you choose? You need to plant these plants. You need to do test mock-ups. And you can see on the left, you can see the mock-up. It didn't work out because there was not enough water. It wasn't so. You have a living species. Our facade is getting living. Yeah, it's a living facade. So a couple of them are plants. And what's interesting about this one, it's a kind of challenges. You start designing certain planting pots. They need to be drained. If there's strong rain, there's too much water. There might be too little water. So you need to have a kind of system to get water over there. You need to ensure maintenance. So the gardeners need to walk along these kind of things. So it's a lot of things that you have to consider. It's in the end a completely different facade system compared to what we traditionally do. But if we say that we want to get our cities in a more better environment, we want to do something about the kind of micro-scale kind of environments of the city. This is a kind of couple of photos from the construction. It's all prefabricated, the plants in the boxes. Now you can choose which kind of plants you're going to take. I mean, these are kind of, for example, plants, they follow the rhythm of the nature. So you have winter, you have autumn. There's some other plants, they are always green, but in this case, the client wants to have something that shows also the winter. Of course, this is not the bright green that we want to see. It's more kind of brownish. And but this is what the client wanted. Actually, the installation and a couple of slides. And this is how it is built. It's a really nice example. But I would say, can we also build such a thing in Dubai? Put a question mark behind it. I mean, green is not always green. In the Middle East, we have no natural water. So all of the water comes from desalination plants with a lot of CO2 carbon emission to get the water. But in such a thing in Dubai, I would say, it's not really green. It looks green, but in reality, it's not green. In a moderate climate like Germany or kind of Europe, this makes sense because we have enough water. Now going on about looking to the future, we're currently doing a couple of research together with the institute in Stuttgart, with the ELAC. We call it digital twin. And this kind of system has a lot of partners. Fraunhofer, you can see a lot of big names over here. And the digital twin is a kind of VR reality where we do the design of the buildings and then we hand over a digital model to the facility management of the building. So from the design to the operation. But in a way, and this is a bit of the kind of new approach, for example, this is the double skin facade system. And we also see currently the way that our facade systems are getting more active in terms of active ventilation, active shading, and so on. So this system is a kind of relatively simple that we now started using VR glasses. So you walk along the building, walk along your facade, you can see every single unitized facade element has a sensor, and each single unitized facade element can tell you what's its current condition in terms of shading, temperature, and so on, and so on. There's a small video, I hope this works. I think there's no audio, yeah. So you can see here the gentleman putting on the VR glasses. And then when you start looking at your unitized facade system, there's a sensor at the top. And the system starts communicating with your VR glasses. And within the virtual environment, you look at the kind of unitized panel, you can see certain parameters, what this unitized facade panel currently has in terms of wind speed, humidity level, and so on. So you walk along, and you then grab certain conditions on the unitized facade panel, see all of the data. And then you can see if the facade, for example, has a certain malfunction, something isn't working, something's broken down. You can log in as a certain service personnel, as the building owner. You can put the shades up or down with just fingertips. Because we see that previously some of these facade systems, and some of these active facade systems, they have the issue that the building owner has one computer and it's far away, so you walk through your buildings and every unit you can just touch it and see what's the current condition, how does it work, some issues, we need to fix something, and so on, so on. Is it the future? Potentially. Is it kind of technical gimmick? Maybe something in between, but we think it's a useful approach of doing new things, doing things a bit different, and being smarter, and just using the technology that we currently have. Just going to go to the next slide, yeah. Now, these are the last couple of slides. I think the half an hour is almost gone, so I'm going to be quick over now. So what's the future? We're at our office, when at Sobek, we always want to think ahead. What's the future? And I'm a guy, I'm working a lot in glass. I'm speaker at glass conferences. And so we've got to think about, because in the end, people like glass. And if you look at certain properties, people still like the floor-to-ceiling glass. Everything is glass, full-height glazing, compared to kind of punched window with small windows. People want to see. People want to have the light. People want to have the vision to the outside. So why don't we build a kind of monospace? So we just build a kind of glass box. Yeah. Of course, people say it's completely crazy because glass is very weak in terms of solar shading, in terms of U value, and we all know glass is brittle, it's going to break structurally, it's weak, and so on. But why don't we give it a try? Yeah. We need to see where we want to go to. Of course, a lot of technical challenges. Yeah. So this is the kind of idea. The idea is to have a kind of switchable glazing monospace, just completely glass. So you're almost like outside. Yeah. This glass controls the transmittance, the solar radiation. We're also able to actively control which spectrum we're going to transmit from the light. It's going to be without any aluminum. Sorry, Arvind. But it's currently designed as a kind of glass shell. Of course, currently we cannot do it. But we want to see where we want to be in like 20, 30, 40, 50 years. What's the goal? We need to see where we want to be. Yeah. So this is the kind of plan, and we built the first kind of thing, the first mock-up at the E-Lake in Stuttgart. It's a kind of load-bearing glass shell, just glass, no aluminum, load-bearing glass with a titanium ring on the outside, so this kind of steel ring. It is titanium because titanium has the same coefficient of thermal expansion as glass. This is how this kind of thing works, and this was built, I think, more than 10 years ago. It's still there, survived snow loading, and so on, and so on. We're not there yet in terms of solar performance, U values, so don't get me wrong, we're not there yet. But we start evolving year by year, these kind of things. And this brings me to the end of my presentation. I say thank you for the audience. And Arvind.
Thank you, Ben, for this wonderful journey from talking about microclimates in cities. And then you transitioned into talking about user-centric design and then green facade, and you showed us a little bit about the future looks like. I don't have a question, but rather more of an observation, and probably you can give us one thought from here. You worked in several countries. You worked from the Middle East and Europe. What do you think is the next constructible technology? You've shown us 30-year vision, but in the next 5 to 6 years, especially with the kind of clients you work with in Saudi Arabia who have great vision, what is the next buildable breakthrough technology?
The truth is that quite often, I've been showing a lot of fancy stuff over here. It's quite often, it's not the revolution, it's the evolution. You usually take existing systems and you just modify a bit to come to the next step. And I think it's always, it's evolution. It's we see a lot of crazy architectural designs. Like especially Saudi Arabia currently has big plans, big projects, mega projects, challenging things. But quite often we break it down to relatively simple facade systems, of course optimized in a certain way to achieve the kind of design intent, better thermal performance, and so on. Because we need to work with what we have right now. We still can have the vision, where we want to be in like 40, 50 years, and it's good to do this research. And then step by step, we take certain parts. Oh, this is already working. Put it into from the future into the present. This is the kind of things. Of course, we always need kind of industry partners like Vicona, like Hydro, to kind of realize these kind of things. But I think this is how we need to do it. This is a kind of evolution. This is how we can make our world better. It's how we can make our system, our facade engineering better, and both at the designer and also supply as you are.
Brilliant. Wise words from Benjamin Beer. A big round of applause for Benjamin. Thank you so much for your great speech. And we move on to our next speaker. He joined Schmidt-Hammer Larsen in 2010. He's a skilled design architect who works both in concept and competition departments. Throughout the years, he's worked up a portfolio of various projects in Scandinavia and China, including the most recently prestigious VIA in central Oslo, which used Vicona systems, and also working on projects which involves a lot of wood. When I asked him what you do and love to do in your free time, he loves to spend time with his family and also likes to play drums. Ladies and gentlemen, Sweenang Cherka.
Close. Nice to be here in Frankfurt. Yesterday I had a Frankfurter Platte. Hey, you know what that is? It's like Blutwurst and the Frankfurter. It's very nice sauerkraut. So now I feel very much welcomed to Germany. But I'm going to speak about facades and architecture the rest of my time here. But it's nice to be here. I'm going to try to share a little bit about what we're doing in our design office and share about a few of our projects. We are an international design studio called Schmidt-Hammer Larsen, or SHL, and we do projects all over the world, but specifically in Europe. Obviously, that's where we're based, and we have projects in China and North America, but really all over the world. We're ranging in different scales from the smallest pavilion to the, as you can see here, to the top right corner. It's the world's largest energy plants in China. So we do all kinds of projects, but we do have a design methodology that we believe is central to everything we do. Even though the project is large or small, there's a common thread that creates a so-called DNA. And although we have the same methodology, we have various different outcome and diversity in a way in how it responds, because it's really about how we respond to the context of where we are. That's very important to us. We don't build the same or respond to the same environment, let's say, or settings anywhere. We need to be very focused on the location and the culture. So this underlying principle of contextuality is a building block that sort of undergirds everything that we do, and our aim is to in a way resonate with its environment, also in terms of materials from the large urban scale seen from afar, but also I would say as you move close and you get to touch and feel and you get a sense of the tectonic and tactile qualities of the project. And of course, in the end, it's about creating great places for people to meet and to live and to share ideas and basically create a community. So with that in mind, I'm going to try to go through 5 different projects that we did over the last years, and we'll start off with projects that are placed in a mid-sized Danish town of Hjørring in Denmark. It's one of the smaller projects, but it's not the least by any means. Already in this image, maybe you can get a sense of the duality in the project, in the facade treatment. The facade is closely linked to the concept of urban rooting, or a sense of belonging when you look at where we are placed in the world. It's a theater, and a theater is a sort of a catalyst for cultural activities, and really an urban power center. And this is Danish. It reads basically the living room of the city, which I think is a good way to put it. It's a place that brings people together, and it shows that the building really works as intended, and also in a way fills a gap of something that was needed. The space inside the building they're organized to create a feeling of flow and openness, both visually but also physically. It's kind of like a city within a city, and in scale that corresponds with the urban fabric that we see in this town of Hjørring. So it, in a way, becomes an extension of that city. Scale is something that we work with, of course, becomes an important factor in the way we treat the various functions of this theater. So there are actually it's like 3 different stages, and then you have the lobby, and everything is organized in a series of boxes that are again scaled in relation to the city. Of course, you have in between this I would say this space of plazas and streets where you can walk freely. It's the ground floor becomes this public space for people to visit, even though you're not there to see a theater play, but you're there to basically be part of a city and meet people and maybe drink some coffee or whatever you want to do. It's totally open to the public. So this attracts a wide range of users, and it's there to basically support the life of Hjørring, this city. Also, you can see that there's a lot of daylight coming in. That's also a very important factor in our projects. Not so much when you're on stage, then no daylight. And this is the main stage, which is basically arranged like a circus, and to get this more intimate relation between the people and the actors. So the appearance and materiality is what we think of as a modern interpretation of the classical theater. And what does that mean? We believe that a theater has a distinctive appearance in any city, in any cityscape, first of all, and often with the use of sophisticated materials, and that makes it unique and something special, something more elevated in a way. And Vendsyssel Theater is construing the theater experience in a modern way and resulting in this very simplified but still intimate and inviting building. We have the rust-colored Cortain steel, which gives this warmth and robust character to the project. But it also has a slight reflection and red tonalities that we find in a lot of the brick buildings nearby. Cortain is also has this matte and diffused way of reflecting the light, which kind of accentuates the material surface and gives this changing image of light across the day. And the steel also helps us creating this precision that we find very important, and it enables us really to define these boxes very sharply. And the story is really clear. I was talking about these boxes that are set up in a sequence. And on the other hand, you have the glass cladding, which is the one that sort of interacts with the quartane steel as the other thing, the duality that this facade is really all about. And we have clear reflections and smooth surfaces, very much unlike the quartane steel, and it contrasts this tactility of the quartane. And I think this duality is what brings the architectonic tension and a little bit of poetry to this building. The glass is also backed with a shading of different colors. I'm not sure if you can see. You have the light pink and light green behind the glass, and it kind of gives this emphasis on the magical, if you will, atmosphere of a theater. And at evening, it really comes into play with the backlit panels, and it really brings out the life and the mystery of this space. So it becomes kind of like a performance piece on its own in this place. So. I'm going to jump to the next project. We've just been to Denmark. Now let's move to Oslo, which is a project that we did. It just recently finished, I would say 21, but it's a project that we've been working on for quite some time. Also with Vicuna as a partner there. I think we started more than close to 10 years ago with this competition in Oslo, international competition that we won, and it's basically it's a story of creating a new open block in some well, let's say a block that was previously very closed, as you can see here in the top left. It was an existing building, and we wanted to create a new place where with ability to crisscross and also invite people into the center of the block. Previously, it was closed, and it was more like open during office hours, let's say, and this. The project that we have today is more or less a public open plaza. And then, of course, we always consider very carefully the volume when we are building in our cities. So this is a very large building. I'm not sure if you can see it, but it's around 60, almost 70,000 square meters that we had to somehow try to fit in central Oslo. And I think it worked in the end. So we're working a lot with variations in heights and to try to massage the building into place. And the project is really quite close and true to the first sketches that you can see here. It's a city block that defines the streets on all four sides, and at the same time it invites people from all four corners. So it's like an open, I would say, city block with portals on every corner. The sketch also indicates some kind of a duality in the facade, the way we treat the facade. So again, you have like a facade facing the street and another facade that sort of reveals a lighter touch on the inside, the internal parts of the projects. So when you enter the courtyard, you get the sensation of a really unique and intimate space, actually. It's not a huge space. It's not a huge courtyard, but it has this very nice human scale to it. And like I mentioned, it's fully public. Anyone can go there any part of the day. The office lobbies, because it's an office building, basically, we decided to put all the office entrances to the courtyard instead of facing the streets in order to attract life and attract people into the center of the building and to generate some life on this public square that also we have a huge, I would say, fairly big skylight, as you can see here, that brings lots of daylight down into the plinth of the building. Now the terrain there's a level difference of more than 10 meters. So basically you lift the terrain up to a certain level, and you put a lot of program, mostly retail, in the plinth. But this skylight was an important feature to bring daylight into the space below. So the courtyard facades, this is a picture of the courtyard facade, is very different from the street facade. So again, you have this duality of facades, and they support this idea of this dichotomy between the very rigid and urban streets, grids, and order, and this more fluent play of curved geometry, but also this verticality in space that sort of reaches up towards the sky, if you would. The facade's curvature helps always lead to around the next corner and through the next passage. There's a way to sort of engage with people as you walk through the space from one end to the other. In terms of materials, we were looking at copper back in the day, but we didn't end up with copper. We ended up with cladding of stainless steel that also has this certain warmth that we were looking for and the client was looking for. And we always picture this space here as coming kind of like into a forest, and then all of a sudden you have a clearing in the forest, and there's a little pond even that reflects the sky, and you can sort of be surrounded by this row of tree trunks, and then you have all these reflections. The sky actually really reflects the lights down into this courtyard, which is again not extremely big, but it's just perfect and very intimate. And these are some of the sketches from early on, showing what our intentions was with the facade. It's the street facade. Again, it's not the one I just showed, but it's the facades facing the streets. A classic, I would say, design that works well with a unitized system, double skin, naturally ventilated. That was the sort of the starting point for us. And of course, protecting the solar shading that is needed behind the fourth layer of glass, because you tend to have some issues, let's say, with exterior unprotected solar shading, and we just didn't want that for this building. Yeah, I wanted to show a picture of the mock-up that we did together with a facade contractor, and I would say a lot of our time was spent solving the corners between these two different facade systems. Actually, the street facade, the one to the right, is a closed cavity facade, and the one to the left is a single skin facade. And the street facade is a very classical structure. It's a grid of limestones, and it's kind of like an interpretation of the modernist buildings that you see in the neighborhood, which is a lot of modernist buildings from the 50s and 60s with a high level of detailing, and we couldn't do any worse. Anyway, it was sort of again trying to respond to the qualities that we have in this area. I believe it's one of the first closed cavity facades in Northern Europe. Someone told me that, so I guess it's true. And I'm not sure how I'm doing on time. The time flies very fast. So I'm going to skip to the next. This is a project in Stockholm that we won just recently, and I'm going to be a bit quicker. So we are in Stockholm, and it's a project called Victura Campus. And we are in a place that is very busy in a way, where a lot of different neighborhoods meet together. So it's quite a complex space to sort of design anything. So we're trying to respond to all these different factors that are going on. We have the park on one hand, and then we have the old Stenstaden, which is kind of like the old 19th century neighborhood, and some new developments as well. And we're trying to engage in this dialogue with the city. So this project will be the last puzzle in the last piece of the puzzle, I would say. And you have lots of traffic. It's lots of heavy traffic and trains in the nearby. Most people will arrive from the north, and here we are welcoming people with this green urban plaza that connects with publicly accessible interiors from the inside and to the outside. A few words about the facade. We working with heavier materials and different types of stone. Again, because we're working close to the Stenstaden, which is directly translated stone city, right? And so the facades belong to the same building, but we are trying to work with variances, but still within the same design language, because they are referring to these buildings are I would say this project consists of several buildings with several different facade skins that are facing different directions, if you would, and thus they have a different materiality and a different design. So basically, we have two facades again that play each the role on the left and on the right, as you can see. The office building is this one, and it consists of red stone and terracotta, and with details in light aluminum. And it's also thought of as a unitized system that easily can be assembled in a factory and brought on site for easy installment. And it's a fairly new win for us, so it's going to be interesting to follow the project in the years to come. I'm going to talk a little bit about another win that we did here just recently. I guess I'm going over time now, but it's what is going to be the tallest timber structure in the world. It's going to be a 100-meter high timber structure in Switzerland. And just to give you a little bit of the backstory, we are in a city called Winterthur. It's not too far away from Zurich, and it's very much known for production industry of locomotives and trains and so on. And today, the city has become a kind of like a progressive place of higher education and culture, and so there's a lot of history going on that we, of course, would like to bring into our projects, if you would. So they cherish their own 19th century industrial environments that you can see a few pictures of here. And the architecture exhibits this high degree of details that is very characteristic for Swiss architecture and also from this time. So that's going to be a transformation hub for this area. So our design proposal is we're trying to open the area by creating attractive outdoor spaces, first of all, that is calling people again to interact and share and create a culture and an environment. We were, in this case, inspired a little bit by the spaces and the breaks that naturally occur in the industrial architecture in this area, in these big factory halls and this little narrow streets between them. So we're using 4 buildings to frame the landscape, and then we have basically retail and restaurants at the street level, and this will become its own sort of distinctive place and have its own distinctive identity. Yeah, the building is residential buildings, and we create a variance or let's say like a alternating pattern in the facade by flipping the floor plan. But it's every second floor is basically flipped, and you get a little bit of you get to break a little bit of the monotony in the facade by doing so. And the materials that we are proposing for this project is also connected to the heritage that you see in the Winterthur with all these factory facilities. So we have a dark red and yellow terracotta bricks combined with details in this dusty green color that we like, and this color palette again reflects the historical buildings that you have in this area. Otherwise, the buildup of this facade is prefabricated, and we're also trying to think of an easy way to dismantle the elements as well for this project. And the facade is not trying to hide the structural elements, sort of the structural system, but rather emphasize. So it's a very neat and clean strategy for the facade. It's a grid, but sometimes we have double height spaces just to not make it too. Anyways, so. The architects, the competition was really about to use a newly developed structural system and see what you could get out of it. So it's already a system developed by the client in collaboration with ETH. And so that was the starting point. So it's really a wood or timber building in every possible way, and this is what you could expect if you were to buy one of the apartments and have a really nice view. The project is hopefully done and due to finish in 2026. So there's a few years to go there. I'm not sure, do I have time to take the last? Yeah, okay. So I just want to, because this is another Vicuna collaboration, so I thought I'd bring in this last project that we won again in a competition a few years back. Now it's undergoing, so they have started the construction. We are in the oil capital of Norway, called Stavanger. It's also fairly small in by German standards, small city. On the west coast, and the competition was about making a high-rise on a very narrow site, and it was very clear from the beginning that this is going to be a landmark, so it's going to have a huge impact on its surroundings, obviously, and also that we wanted to get use of this 360 view and design it from a 360 viewpoint. It's mainly office in this building. We do have some common functionalities or a program at the top floor, and there is even a church in the base of the building that was there already. So there's interesting mix of programs here. From the interior, it was important for us to get maximum daylight. Again, very important. But also here to have glass spanning from floor to ceiling. Imagine being on the upper levels, and you would also be able to sort of have a better connection to the ground, so you are able to see very clearly where you are in the world. And so there are no obstructing elements. And originally, the intention was to get a building permit for high-rise in Norway as a Norwegian setting. 117 meters was the ultimate goal here, which would make it the highest building in Norway. But right now, there's a very intense debate going on in Norway, whether we need high-rise and what is the necessity of high-rise. What do they bring to the table, so to speak? And so just a few weeks ago, the first approval came for a plus 100-meter building in Oslo, the first one in 30 years. It was not our project, but it just says something about the climate that we are in right now. So the tower has been adjusted since then, so we're not. This is not a high-rise anymore, by any means. We had to sculpt the volume as well to maintain a proper distance to the neighbors. There were also a bit of an issue there. So as you can see, the lower part of the building has been pushed in, and there's a little setback there. But all in all, the facade is really sort of wrapped around the building, 360, with the corners that are curved. And towards south and west, we do have this closed cavity system. And again, we're splitting the facade between a single skin and a closed cavity system. So I believe a lot of the work has gone into solving the detailing between these two systems, kind of like what we did for the VIA project in Oslo. And for this facade, it's clearly an aluminum facade. We tried to work with different variations of anodizing to create some kind of a play in the facade and the way the sun sort of reflects the facade. But it's very clean concepts, aluminum and glass with the spandrel panels. Yeah. Also, without becoming too sterile, it's important for us to work with some kind of a depth in the facade. So that's why we have these, or one of the reasons why we have these aluminum boxes. It's a bit difficult, perhaps to see in this image, but we're always studying these smaller things. Like here, we're trying to try to get the correct depth of the aluminum frames, and again, a bit hard to see, but the image to the right is there you have the boxes becoming more shallow towards the top in order to get a little bit of more reflection, just a little bit of lightness towards the top. And towards the top you also have the roof terraces that are also for common use, like I mentioned, having these great views over the oil capital. Yeah, I think I do have a couple more images from the entrance, and I'm gonna quickly go through. I mean, we sometimes we have these opaque panels, as you can see here, and yeah, I mean, we try to incorporate a green in this image. It just shows that we are working with the green elements in a very simple way. And the previous image was showing the entrance. So we do have two entrances from a site that sort of drops around one floor in total. And this is I believe this is the last image. This is the image of the tower as it was supposed to be, I guess. It has shrunk a little bit since then. But yeah, that was it for me. Thank you very much for having me, and good to be here.
Thank you so much, Ryan, for this wonderful presentation.
Yeah.
I think we have crossed a bit of time, but, but before we let you go, we just ask you one question. Working on the timber tower, what were the challenges and what was the outcome now? Are you confident that this is probably the future for structures, or do you think there's still more work to go?
You want me to say wood is the future here? No?
Well, yeah.
I think for architects more and more we're thinking wood,
right?
Because of a lot of qualities that we all are aware of. Also mainly because of the encapsulation of carbon. But yeah, I think it's going to be more and more wood structures, and maybe more and more wood facades as well.
Fantastic.
So, but we don't discriminate. We also work with aluminum.
The good news is we have a very good aluminium wood system.
Yes,
so
yes.
That's for you as well.
It's very good. Thank you.
Over to you, Simon. Thank you so much. All right, for our next speaker, he's been working with Engel Architects since 2009, and his office is from Munich. From 2013 to 2017, he was responsible as International Director for Design for projects in the Beijing office, China. And since 2018, he's been office head in Munich. He studied architecture at Technical University of Munich and Illinois Institute of Technology, Chicago. When I asked him his passion and his free time, he says if he has the time, he would do more of piano and skiing. Ladies and gentlemen, Christian Eichinger, over to you.
Thank you so much for the introduction. I'm very happy to be here today and tell you a little bit about our projects. And obviously, we also thought about the topic of facades, but we're going to treat it a little bit differently because we traditionally are we have a very strong office background from where we work with, or mixed-use projects. But especially in our international work, which also affects me because I've done a lot of international projects over the years, we've done a lot of cultural buildings. And I feel facades have a quite special characteristic in cultural buildings, and therefore I've brought 4 of them. I have far too many slides as well, so let's see how fast I can go. I'll just say a couple of things about our office really quickly. We're one of the bigger German architecture firms. Yes, I am the head of the Munich office, but we have further offices also here in Frankfurt, which is the biggest of our offices, where Jürgen Engel also sits, who owns the place. But our office is also quite old. We're 80 years old. We've been active in this country and abroad for a lot of years and have obviously employees from everywhere around the globe, so it's also a little bit discriminating that I stand here and represent everybody, but I'll do my best. So they're all with me today in my mind. And I think, and this is a kind of dry slide, but I'll still put it there because the first point, not the fact that we're quality certified, which I believe in this context maybe not so important, but the fact that we work iteratively and integratively, I think is a very important part of our work, and it's really the essence of what we do. We don't try to ignore the problem at the beginning and then at some point find out, oh, all of this doesn't fit together. We try to approach the thing analytically, try to understand it, get into the depth, and ideally find a solution that solves it smartly and kind of elegantly. As I said, 4 projects. The first one, National Library in Beijing, is the first or the biggest project that we've built in China up to date. It's the extension of the existing library building in the northern part of Beijing. This is basically what we found when we were invited to the competition. It's a while ago. It's a project that was built in the end for the Olympic Games in 2008. And it's a very complicated question, right? I mean, the National Library obviously contains kind of the wisdom of a whole country. And what do you do in terms of, like, what can a building be, and especially a library? I feel also, obviously, we are in an age where, let's say, everything is changing. It's too simple to say, but let's say, especially in terms of the written word, everything has been changing from, let's say, papers or paper scrolls, which the library also has, to kind of a digital future, right? Everybody reads on the phone, reads a Kindle maybe, I don't know. And this for us was an important and interesting question, how to cope with it, and also how to cope, obviously, with the fact that we are building a new library that kind of also symbolically stands next to an existing building, which is not very old, but kind of is a classical, let's say, communist architecture piece, which has an importance also in the urban structure. And I feel it's also important to always understand, of course, we come from Germany. Germany has, I mean, yes, changes also, but change is slow, and everything is much smaller. China, everything is very, very big. And so the whole surroundings, as you've also maybe seen in the picture before, is basically splattered with high-rise buildings. No? And the question is also, how do you make yourself important somehow as a building, no? as an important player in the city when you are kind of only small, or let's say low, because you can't really do a library in a high-rise very well if you're not in Paris. But anyway, so the basic idea was, how can we cope with this, and how can we also make sure it kind of fits into an idea of what is a traditional Chinese kind of government architecture, if you want, no? Like, how does an important building look in a city like that? And the traditional Chinese building looks a little bit like this. This is obviously the Forbidden City, so we put the highest possible rank, but anyway. So you have a plinth, you have columns, and you have a roof. And this is basically also the idea we took for our library. It's kind of schematic, and it's maybe a little bit dumb, but it's very clear-cut, and you can explain it very well. We have a plinth, we have the columns, and we have the cube on top that symbolizes the roof. And for us, also these two elements, so the plinth and the roof, stand for the two worlds kind of that come together, right? The traditional, let's say, historic aspect of a library that kind of is rooted in the city, that has a connection to it, and the roof that kind of stands for a future, maybe, of a digital library and what to do with it. And I think the other thing that is really important is how to bring the two things together, right? Because, I mean, in the end, you don't want to look at a library from the outside. The question is what happens on the inside and how can you generate something interesting. And so what we did is basically make one big space that connects both the upper and the lower volume, that steps down kind of like a terraced system. You can see it in the middle image there. Oh, the pointer doesn't work. And down there also, what you can see on the right side is the Sikut Quanzhou, so kind of the collection of the most important historical scrolls, like some of the first writings of Chinese characters that have been collected. And this is the finished building, which obviously has a kind of strong present, even though it's a very horizontal building, obviously, in comparison to everything that is vertical around it. But I think this was also a very, let's say, a clear decision from our part. You can't kind of compete with all the verticals around you if you can't really get that tall. You have to work with the width of your belly. So, yeah. And here you can just see a little bit of the architecture. The plinth itself opens itself, closes itself with natural stone louvers, and the top part is an aluminium-clad facade with kind of big windows where also there is kind of a more private reading areas for the people that don't want to sit in the center. But for us, the most important space you can see on the right-hand side is kind of that big atrium reading room that connects everything, and that, funnily enough, I still meet people that always tell me, "Oh yeah, I know that building because I've studied there when I studied when I studied at university," and because they're quite close. And you can see the library obviously is a very big library, 12 million books, so there's also a lot of things obviously underground. Not everything is there to see, and 2,000 seats for reading. One thing, because we're also kind of in a technical discussion here, which is also interesting, is it's a very big steel structure that is floating, and that was constructed in an unusual manner, because the steel structure was built first, then the underground was dug out, and it was kind of kept on little columns, and then pushed upwards hydraulically, and later the plinth was built, which was also quite challenging, let's say, but interesting and worked out fine. So we're very happy. Here you can see interim, the steel structure is built and the columns that just keep it there temporarily, and then it gets lifted up in a big ceremony where everybody looks on to. Yeah. And a second project I brought, basically because it has no facade, which I felt is also an interesting alternative, maybe, is for the Meiji Urban Helix. This is also a competition win. Maybe for those of you who don't know, Changsha is a 7 million inhabitant city in the southeast kind of China, not at the sea, but slightly inside in Hunan. Mao Zedong is from close to there. So not a lot of people know the city, but that often happens in China, that you have very big cities that we haven't heard so much about yet. And they are building a very big kind of urban extension, 38 square kilometers. There's a big master plan by KPF that has this circular lake. You can see it here. That circular lake, and in that lake, because in the master plan there's a big axis that runs right through the middle of it, hits the lake, there's an island. Then they built all the infrastructure, they started building the buildings around. At some point they realized, we have an island. We built that island, we don't really know what we're going to do with it, because we already have a museum. What can we do? They made a competition which we won. Basically we're saying, okay, you already said it, you don't need another building. You need something different. And we decided to kind of work with the public space, and because we anyway need a bridge to come to the island, right? We decided to work with that bridge and spin it up into that kind of this helix-shaped building. So there's a spiraling ramp going up and a spiraling ramp inside going down and leading to the island, and therefore kind of also making that process of arriving into something on its own. And also, I mean, we are not, let's say, inside of a built environment, but we're inside of a new urban construction, so it's still changing all the time. And we propose to make kind of an exhibition for the people to see, okay, this is what we're going to do. You walk around the ramp, you have different kind of podiums with exhibitions, you can have the connection to the outside and the inside, and make people also understand what is happening there. This is the basic, let's say, diagram. No, you have that big axis, you see all the big city extension, you see the circular lake, and you have a question mark where the island is. What do you want to do? And so this is a steel construction which we worked on very, let's say, with a lot of energy also to get it done. It was not very easy to get it built because Chinese structural norms are kind of motivated by concrete construction and not by steel construction, and it just works very differently. But by visiting national expert commission twice. We kind of convinced them that it was doable, also with our partners, structural engineers, and also our Chinese partners who helped us a lot. And we built this basically in prefabricated elements. You can see here the last element on the right-hand side is being lifted in. It's a quite sizable structure. It's always hard to judge, I feel, for me even. I remember still when we had it on the Rhino model, and you always thought, oh, well, okay, it's not so big. And then you arrive at the construction site, and then they just dug the foundations, and you're like, oh, this is going to be sizable. No, but it's about 86 meters in diameter and 33 or so in height. So it's about 1.5 kilometers length if you walk it the whole way. So it's a good stroll. Here you can see a couple of the images during construction. So basically you build the structural core somehow, which consists of 32 steel columns with 30 centimeter width that go over the whole height, and then you hang the ramp around it. And this is kind of the finished. Yes, here you see the section a little bit with the 2 ramps, and here you can maybe feel a little bit the scale of the whole endeavor. It's quite, the ramps are about 6 meters wide, so it's a very, very big structure at the end of the day. But in the whole setting, it still feels kind of like, yeah, not enormous. And the good thing also is, I mean, obviously in the last 2 years you couldn't really travel to China so much, but before I have been there once or twice. And funnily enough, people do actually go there. You know, it's one of those things where you always think to yourself, okay, are they going to actually do it? You know, you build that thing, hope for the best that somebody's actually going to walk there. And it is quite an active space right now, and there's also activities that are planned on the island, because we also designed a public square there with a seating area where they can also do theater, and they do a cinema in the summer there with a big screen. So it's kind of an active place now. Even though our architectural photos are taken before it was opened, because architectural photos don't always have people. Yeah, but here you also get a bit of the feel of how it is going up and down, and how the different views inside and outside work together. One project that has been ongoing also for a while, it's a competition win from end of 2015. In Shenzhen, the new art museum and library. Shenzhen is obviously one of the strongest developing cities in all of China over the last couple of years. Right next to Hong Kong, with a huge development, especially in the tech sector. And at some point, they also have a very big city extension, which tends to happen when you grow so much. And they decided to develop a new art museum and a new library for the city. And it's again a similar setting. You can see it in the back. There's a lot of high-rises already in place. You have an urban development in the south. This is very light. In the south, where you can see, okay, like we look from, basically there's a very big outdoor shopping mall in our back, kind of a commercial center. And we look towards this, and what we try to do, because there are 2 buildings and 2 competitions at the same time for those 2 buildings. We decided not to treat them as 2 separate endeavors, but as one thing together. Because what we also found very interesting, and I hope you see this in our design, is the question of what happens in between, right? You have 2 things to work with, and how can you activate the space in between? Because Shenzhen also is a city kind of with a tropical, subtropical climate. So it's usually quite nice to be outside, I mean, apart from maybe July. But you can actually use the outdoor space very much, and you can activate and bring people inside of the building. And we also thought that having this kind of public square where things can happen, where also exhibitions can take place, is a huge quality. And luckily, the jury agreed with us and allowed us to build this thing, which is under construction right now. As you can see here, it's obviously also a very big building, around 74,000 square meters above ground. About half and half for the 2 building blocks, library and art museum. The art museum and the library are about 80 by 80 meters as enclosed spaces. And then we added this big roof, because obviously as I said before, the subtropical climate, so you have two topics. Obviously, one thing is shading, but the other thing is also rain. There's a lot of humidity. And to cope with this, we proposed this big roof also, and also obviously to give the gesture more strength. This is the library building. I think in terms of facade, this is also an interesting topic. You are working with functions that not necessarily need a lot of daylight, always, especially in a climate that has so much light that if you work, for example, with books that need protection, you can't really put them out, let's say, next to a facade because it's going to destroy the historical substance. If you have art, obviously, even worse, even more so, because, let's say, the current tradition or the current concept of exhibition design for traditional Chinese art works a lot with dark spaces, not with light spaces. And therefore, the implementation of uncontrolled daylight is always a big problem. And you can see this here with our Chinese facade firm, work with basically a parametric system, if you wish. So it's a 4.2 meter long element, basically, that comes in 8 different versions that are opened and closed more or less according to what is happening behind in the facade. So if you have an opening, if you have something behind that needs light, it opens. If you have something behind that doesn't need it, it's the element in the front facade is bigger and therefore covers the facade behind. We made a lot of, let's say, we turned a lot of rounds designing the specific facade and the specific facade elements because the client was convinced that they wanted a natural stone cladding, which obviously doesn't lend itself very easily to these geometries and especially to having this type of double layered. So it's in the end, it's a aluminum hexacomb laminated natural stone, 4mm natural stone laminated on an aluminum hexacomb element that then gets put onto the facade. And while, again, this was a long struggle to get there, the outcome I feel is quite convincing. You can see a little bit the size with my colleague there. And we decided for the lower element. This is kind of an inside view into the library. We can just see that also here, it's kind of we want to shape kind of a living room around a central atrium where all the reading spaces are and the books are then stored outside on the perimeter. And this is a view into under the roof, kind of into this central space where the public activity can happen, and you can see inside the museum space with its big staircases. And this is again a view from kind of street level view, where you just get a bit of an impression. Construction right now is on its way and actually quite far already. We believe that the building should be finished at some point middle next year, spring to summer. This is the library a couple of weeks back. This is the art museum a couple of weeks back. And now the facade construction has been progressing quite quickly. This is on the roof, but you can also see here, this is still not covered, but these are the last images from just last week, where you can see that now most of the facade cladding has been installed already, at least the standard elements, not the pieces that are set back or like that follow those curved kind of impressions into the general shape, where the more the spaces are that need more daylight, because we set back the spaces that need more daylight so to protect them even more from the sunlight. So this is a kind of a still current project, even though we've worked, it's been going for a while. And last but not least, I have one more project, because I also know that there are a couple of people obviously that don't have the connection to the Chinese market. The Great Mosque in Algiers is a project that we've been working on also for a very long time. It's a one competition from 2008, 2009. I had just started working here in the Frankfurt office, and it was a very big team effort. And it's actually a funny story, which I always like to say 2008 was obviously not a very good year for architects in Europe. And this is also true for us, right? In Frankfurt, there was not so many competitions as usual. Everybody was sitting around a little bit worried what is going to happen. And at some point, we saw this competition coming in, and we thought to ourselves, okay, why not try? And I don't think anybody at that point would have thought that we would win the competition, or worse, that we would get to build it. But here we are, and this I feel is actually the nice thing about being an architect. Sometimes surprises do happen. So yeah, the competition in 2008, though there was a second phase. Then after there were three first prizes in the first round, and then there was a second phase that took till the end of 2008. And then we started working on the planning basically already 2009, 2010. And construction started in around 2012, and we finished the building in 2020. Not the perfect timing to finish a building that is meant to get a lot of people together. But at first I'll just give you a couple of impressions from the city and from the way the building finds itself there, because it is a surprising project in a lot of ways, also for us, even though we've worked on it for a long time, and the whole thing and the whole setting it's in flux. No, it's not something where you say, okay, this is a settled city, everything is fixed, everything is clear. It's still a city very much in changing and developing, and obviously having a strong goal of where to go. But you find these kind of situations in the city that we also find very charming, and therefore I wanted to bring a couple of pictures of just to show what the scale of the project and what this kind of statement also means for this country. This is the big highway going from the downtown in the Bay of Algiers to the airport basically, and this is also, the mosque is basically the first stepping stone for also a big urban development that is now on its way, also with more cultural projects. There's the Musée d'Afrique, there's also obviously just housing and office projects that are going to happen in the surrounding. The project itself is around 450,000 square meters, but a lot of, obviously much bigger in terms of just covered space and outdoor space that gets planned with it. In terms of what we were thinking about, let's say, we're Germans, right? So in the end, we always like to have structured systems, grids, some type of rules to work with. And what we worked with here are basically two systems. The first one is 4 squares that organize the basic functions of a mosque, each one set behind the other, with a minaret in the first one. And then the second one is the column. We basically have had the problem that we have a very big building, and it's very hard to find kind of a shape or something to unify it. And therefore, we work with the one column that is kind of modeled on the color flower, and just repeat this element throughout. And this gives the whole building, even though it's very big and covers a lot of different functions and spaces, kind of a one quality that you can always recognize. Of course, as I said before, it's a project that went over a long time. Interestingly, it's also a project, obviously, that had a kind of big importance at some points. Angela Merkel was there when the contract was signed and made sure that we would also sign. And just again, to give an idea of the scale, because this also is something we did for ourselves, because I feel this is also, like, obviously it's very hard to get a grab of these type of dimensions and still understand what it means to be a human inside of them. And you can see basically the tower, the minaret, is basically as tall as Commerzbank here in Frankfurt, so around 265 meters. It's the second tallest tower in Africa right now. And you have the Hagia Sophia and the St. Peter's Cathedral just as kind of comparisons in terms of the scale of the central praying space. again, a little bit light, but you can kind of see, of course, the whole development is not only the mosque itself, but it's also embedded kind of in a cultural center consisting of a conference center, of a big library also, and of a Quran school, and then 12 different functions that are added still inside of kind of a park, from housing to a fire station, a power plant. I mean, lots of different things that obviously are needed for development of this scale. And here you can see a little bit of this is the central section through the mosque, and you can kind of understand the process that you go through, no? From a more public plaza when you enter, where the minaret is sitting, and then through the esplanade, and then step by step, always from one square to the next, going from more public to more private functions, with the prayer hall at the end, and then obviously the space for the imam even one step further. The whole mosque, as is usual, is oriented towards Mecca. And here I just want to show a couple of impressions from the inside, and just to give you an idea, as you can see, I think in this picture it becomes very clear the column has a very, very strong aesthetic and really gives a kind of atmosphere throughout the whole building. Yes, and there's also one height running through for all the kind of outside functions, and then a second height that works to about 40 meters height for the prayer hall, and then there's a cupola on top of the prayer hall. A cupola, I will say, that we did not have in the competition, but that the client was adamant we add. So this is what happened. And here you can see the minaret, and on the right-hand side you see the Bay of Algiers. So also an added quality of this kind of plinth that all the functions are stacked upon is that you obviously have a very nice view onto the seaside also. You can see into the far. And on top of the minaret is not just a minaret, it is kind of a multifunctional tower. It houses a museum through there's always stacks of 5 floors. You can kind of see it here. And they house different functions. One of them is the museum. Others are basically office spaces for the administration, conference center, things like that. And yes, now we progress through the different courtyards. You can see on the right-hand side, this is the washing stations in front of the prayer hall. And this is then the entrance towards the prayer hall. You can see that the public columns, they are on one side, on one height, and then you have the central building that is on the second level, and the cupola on top. This is the view into the main prayer hall. The prayer hall can house up to 35,000 people at one time, and they all have space to pray, basically. The problem is that you can't make them escape all at the same time, because you would need more space than the facade length of the building is. Therefore, the amount of people gets limited to about 20,000 people, but that's still a very sizable amount. And this is the view towards Mecca, so to speak, from the entrance to the prayer wall. And then here you can see a couple of the other buildings on the south-hand side, the library, the conference center, and the Quran school with the dormitories. Just some impressions from there. Auditorium, as I said, and here this is a view into the library. I think here you can maybe see, obviously one of the big topics also was the topic of, let's say, ornamentation in general, which has a very different quality, obviously in Islam, than it has, let's say, for us as I'm Catholic, but let's say in Protestants have a different view on them. So, of course, this is also something where we worked with a lot of people that helped us understand, and that basically also not only helped us understand, but understood much better than us, and also negotiated with the client about what was possible, what had to go where, which text goes where. It's obviously a very rich kind of environment, and I think it was a very, very interesting, also sometimes obviously complicated task, but in the end also very enriching to us, to the team and our office. Yes, this is the final images I can show you here at night with the Bay of Algiers, and I have a small video that should maybe play also. Yes. Yes, I think this gives a little bit of the atmosphere also of how the building sits in the city and the relation to the bay, and maybe also, of course, the question of the scale, which I feel is, of course, is a very, very big building, but it also has to kind of convey its meaning over the distance of the bay into the downtown. I think this is one of the big questions that was discussed also always when the design was finalized. That would be it from me. Thank you very much for your attention.
Thank you so much, Christian, for this wonderful presentation. One question for all the aspiring architects who are trying to go global. How do you manage as a German firm dealing with the Chinese clients and African clients? What is your one piece of advice to architects who want to go global?
Don't be afraid. No, to be honest, I think just a general sense of openness and always understanding that, like both sides, so to speak, it's the same as here, right? Everybody's a human. So, usually just be open and honest. Things usually kind of work out.
And that's really your credo, right? Architecture begins with people.
Yes.
That's fantastic. Ladies and gentlemen, Christian, a big round of applause. Thank you so much. Okay, we started from Dubai, we went to Copenhagen, we went to Munich, and now we come South Europe. Our next speaker is from Chapman Taylor. He joined Chapman Taylor in 2002. He's a PhD and from the University of Madrid, having supervised and coordinated projects and site works in several projects in Spain, Qatar, Turkey, and Saudi Arabia, amongst others. When I asked him what he loves to do in his free time, he loves to travel the world and also likes to play the clarinet. Ladies and gentlemen, please welcome Giuseppe Laferla from Chapman Taylor.
Thank you, Irvin, for the presentation. Everyone to wait almost 2 hours. I try to go quickly. I want to show a couple of projects, if it's possible. No, yeah, we are. So, thanks for staying here. And just to introduce you, my company, Chapman Taylor, is an international company. We work, we have 50 years, more than 50 years of experience. This is our numbers, projects, but what I think is important, we have 15 locations, 50 offices around the world, and we work with 35 languages, with 45 nationality. For us, it's very important where we work and in which place we work. We work all around the world. Our values are to be creative, to be responsible in our design, to be collaborative, and to be client-focused. For us, it's very important. Of course, the core of our values are the people. This is my colleague in Madrid offices. We work around the world in all the sectors mixed use, transportation, workplace, retail, residential, a master planner, offices, and we work or we deliver all type of services linked with architectural, design, interiors, graphics, since the beginning of the projects, the first phase of a sketch to the end of on-site construction. So what we do is architecture, but we give this our vision with our responsible design, because as we say, we work for 3P: people, places, and world. For us, it's very important to take in consideration all the aspects of our responsible design for the scope of our works. Now, just want to show 3 types of projects, different scale. This is a mixed use in Portugal, in Lisbon. It's a new project in a landmark building in Business Park. It's we have done just in Madrid this year. This is another project. This is another type of project. It's an office refurbishment. This is a very new building in Madrid, Los Cubos, but in 35, 40 years, it was a whole building in all the aspects, the use and for the energy consumption. So we refurbish all the building. Of course, we retrofitting the facade. This is not a new project, of course. Another new project, but another scale, is this one. It's a mixed-use destination in Saudi Arabia, at north of the city center, near the airports. This is another scale because it's a master plan with all type of users, all type of the buildings, all type of facades. Of course, it's the same climate situation, but there are different of buildings, users, and so different type of facades. Now, to go to the answer or to the meeting, how can future inter-building envelopes and outstanding facade content be planned and implementation in international context? I want to, of course, each of us has an answer, but just I want to mix 2 concepts to give you an answer. The role of the facade and the technical performance of the facade. We play with two elements to have a vision for the facade in the future buildings. For example, here, to develop the first part of my answer, we know 2 of them of this building. This was a vision of the beginning of the past century. These 3 buildings were done, or the project of the 3 buildings was done along 1 century. The other one is one of the last projects in Egypt. The London building is very famous. But what I want to show you is what is the link between 3 buildings. The idea of Ms. van der Rohe is the transparency of the envelopes. The building is not so enclosure. Also, our colleagues explain very well these topics. It's not an enclosure. There is transmission, there is interchange between inside and outside, lighting, visions, energy. So we have to deal with this material, the lighting, the energy, but also the facade, which link this is the image of this 3 facade, to make an iconic design for the future. This is very important for architects and for clients because they ask us to be their best projects. So for us, it's very important. But we work with a specific technology in this project, usually. It's the glazed facade, the curtain wall glazed facade. This type of technology, of course, now we are deal very well with this facade. But during the first project, the vision, they didn't have the technical solution to solve the problem. Now we have, but we need to deal with, I think, more than 2 aspects. But for me, 2 aspects are very interesting. the energy saving or the energy, the sustainability of the building, the energy transmission, and the quality of ambient we build for the human being. So we have to build with the energy efficiency of the building, in this case with thermal comforts, to achieve the indoor environmental quality required by a part of the international standard for the clients, for the people. So the first one, I think we achieved this issue to improving the thermal performance of the facade. But the second part, or the thermal comfort aspects, I think today are still not very well achieved, because as we know, as users, we see when we live or we stay for a long time near the glass facade, we experience a thermal discomfort. This is the second part of the answer I will develop. In this case, I use 2 cases study to show this, or to develop these 2 answers. With a project application and with a project investigation. The project application, it was it's an hospital in Doha. We were invited to a competition during the stage of building of these buildings. It was, at the beginning, it was an hotel, then the client changed during you can imagine, all the structure were done, all the shapes. So we must work with the facade, with the character of the facade. So we decided to implement in the facade very simple elements, new technology, digital technology. So we won this competition with a simple facade, covered curtain wall facade, with a digital element, new digital element that give you a new vision, a new role of the facade, because the facade doesn't express all the time the same character. The facade is part of the character changing during the time. You can show even what you are in your mobile in this facade. So this was, I think, the idea of this project, change the vision, the point of view of the facade. So we create a landmark, of course, not only for the night with a light facade, but also to create a pattern, making this pattern as a brand of the facade, and working with the scale of this type of pattern. O is from inside outside, O is the precision of this facade. Also, because this is not only an hotel, an hospitality building, it's a hospital building. So there are patients all the day inside the building. So the human being is very important. Yeah, just to show you the technical issue we had to deal, because the client has a very clear vision. They want only double glass facade. They didn't want double facade, double skin. Usually, it's used for this type of facade. So we had to deal together. I think it's the most important achievement in this facade, in this project, was the integration between our projects as designer with the manufacturer, with the experience of the manufacturer, and of course by the requirements of engineers, because we are in hot climate, so the facade, of course, need to be very with EU transmittance very lower and so on. So we to face this project, at the beginning, we need to understand how each layer of this facade is made, how its work, and so how it can be assembled, because it need to be assembled in factory and then fixed in the structure that we just had. So, but this is an example working with glass experts, manufacturer, with digital manufacturer. As you can see here, for example, here, this is the layer where is the dots of the digital facades. It's very important when is made or what is the process, because of course the fritte facade, as you know, you are almost technician, is a painting template, but the templating process can be destroyed the LEDs or the layer, control solar layer, so on. So it was very important to understand the process. Finally, to have a double gas unit stick to a frame, and where the modules contain the digital devices, open a module for future maintenance. And then, again, in the factory of facade manufacturing, to assemble with a unified model. So this was one of the changes, but all this in a very short time, because as you know, in Qatar, each building should or must be opened this week before the World Champion. So this is another building that this week must be opened. So, of course, for us, the other facades are very important, but we saw with high-catch idea, but with more traditional louvers or glass facade. Here you can see some mock-up faces, the facade without LED and with LED, where we have to design each dot of the lattice to now cover the LEDs. Here, this is a vision of a normal glass here with LED facade. This is a mullion. Open module, which contain all the devices to control all the facades. This is, I think, three months ago, a photo 3 months ago during the construction phases. This video is homemade by a colleague, I think 3-4 weeks ago, during the first stage of checking of the video. So, yeah, you can see the possibility of this type of facade. The transparency of steel transparent, the facade during the night. You can show anything, yeah. Even the final World Cup, yeah, of course. So, another one project, this is a project investigation linked with the second part of the answer, with the thermal behaviors of the facade. It's linked with my PhD in research in University Polytechnic of Madrid. I tested here the university in the campus as a laboratory, an exterior laboratory, just lab where in this module, 3x3 meter, you can test different type of facade. These are two twin model where you test two type of facade and how they can work. At the beginning, just to give you a picture of what is the problem and what I to try with this technology. As you know, as before said, it's very important when we have a glass environment, even with a very very low U value, the radiant temperature transmitted by the glass, because as we experimented near the glass, we can have a discomfort, local discomfort, or even as wool, body wool discomfort. We know the international standard try to solve this problem, give us methodology, how to calculate the index of thermal comfort. There is, for example, a Pareto mean mode or so on, but linked with the thermal sensation of the scale. When the value is 0, the person are comfortable near to this glass facade or near to other facade. Of course, no transparent or traditional walls don't give this thermal asymmetry. So this we have to achieve this neutrality, sensation neutrality, with transforming the facade as an active element. There's actually in the market there is some technology to make this. Can be with the water inside the glass or with changing phase material. I use this technology because I think it's the most simple technology. It's just a double unit facade with low emissivity layer, like this. Well, of course, this is with laminated, but it's the same one. This layer, as we know, it's a metallic layer, transparent metal layer. So if you electrify this convert in a radiator. It transmits, emits low infrared radiation, so it can be used as a radiator. So this is the basic of this technology. Of course, it was tested along 2 years, both model, with one with the standard glass, the other one with the radiant glass. In all the condition, on the weather condition, lots of data we're getting, Finally, I divided in different periods to make a comparison between two glasses, to choose some case study to compare with them. I don't want to bore you with graphics, but just to understand, I monitored every type of temperature inside the room, each faces of the glass, all the faces of the wall, operative temperature, radiant temperature, air temperature inside the building, in the center of the building, as international standards suggest, and like this case, along all the day, and I calculated, of course, all the index of thermal comfort. There's the evolution in 1 day. It's between radiant glass and standard glass. But apart of this, I study how it is radiation, how is distributed inside the rooms, the temperature, how is change the thermal comfort inside the rooms. So this is a typical mean radiant temperature for typical glass, as we know, probably, because this is what we expect. Near the glass facade, the temperature is lower than the back rooms. This is the same model, but with the radiant glass, where the temperature, the mean radiant temperature, it's distributed all around the perimeter of the model. As we see here, if we consider the radiant asymmetry for each pound, because it was calculated for each pound of these grids, we can see that with a standard glass, the radiant asymmetry is between 5 and 7 degrees. In the radiant glass, the radiant asymmetry what give us the non-comfort state of temperature is this, because it's almost zero. So the asymmetry is almost zero. Just to resume, this difference between the index of comfort in these two models. to have a neutral sensation near the glass here, near to zero value. We have at the back of the rooms a sensation of hot. And we know the international standard give us or suggest to calculate this in the middle of the room. But if we take into account all the rooms, there is a very lot of difference between, this is the index of comfort, not just only temperature. Whereas in the radiant glass facade, we have all the same index around all the rooms. So if we, in this case, case A, I think it was 20 December of 1970, this day, with 22 degrees inside of temperature, with the same temperature, we have this hot sensation. So in this case, we can lower the air temperature, the operative temperature, to give zero value of index of comfort. This means, in this case, was with 18 degrees. This means 4 degrees less than standard glass. So as conclusion of this work was, radiant glass can achieve uniform spatial distribution of thermal comfort level, even in perimeter zone near the facade. It is not dependent on the exterior climatic condition, and of course, from the distance from the glass. Whereas, in the other facade is not possible. Also, it's possible to reduce the air temperature and the operative temperature in the radiant model to achieve the same level or the best level of index of thermal comfort. So, just to conclude, what's next? This is a video, I think it's one week ago, yeah, more. I think in both aspects of my answer is why not use the facade not to express all the character of the building, but to communicate with the surroundings. For example, this is an hospital, but could be a museum showing their own or their temporary exposition. A city hall where the institution communicate with the surrounding, with the citizen. Why not? Why we don't have to think for the facade with another role? And the other aspect with the radiant glass, why not? In this case, to make more layers. For example, PV transparent layer to produce the same energy we use to hot the inside. So I think the next is perhaps sometime to use the same technology, but with a new vision or a new combination. Of course, revolution are very important, but sometimes we also we have to play with the technology we have with a new vision. Thank you to everyone.
Thank you so much, Giuseppe. I personally know this project. It's unbelievable how you were able to execute this at such short span of time, as well as just talk us through, just maybe quickly, how were you able to convince the client to invest on a technology like this, because it's not the cheapest. There are other options, like you mentioned, secondary screen and easy fix, but have a transparency and have this big media facade. How easy or how difficult was it with the client?
I think it was for the not revolutionary, because this it's not a screen in a facade. It's the facade
itself.
Yeah. So I think it was the key. They reduced the part of the LED facade because the cost, of course. Also because the time, we didn't have time to produce in factory this glass. But I think that the key was to transform the facade in a new vision. It's not a simple showcase as we are used to see in a shopping center or in a canopy. No, it's not a showcase. it's a facade that communicates with the surroundings. I think it was, and because of the first one also. So I think it was the key to convince the client to invest in this very expensive facade. Perhaps I don't know exactly now where it is, or we will know how was the cost. But of course, the facade cost almost all the building.
Yes,
so
sure.
it's very expensive. It's a very expensive work. But I think the idea, as Ms. Van der Rohe has the vision is important for the projects, also
brilliant.
for architects.
Yeah, hats off to you. Well done. Ladies and gentlemen, Giuseppe from Chapman Taylor. A big round of applause. I think it's very important to acknowledge all the speakers who have done a fantastic job today. Let's give one big round of applause for their time today. Yeah. And now this brings us to the close of the 6th Next International Facade Seminar. Thank you so much for your time. Thank you for the audience online. You've been a fantastic audience. And thank you, everybody, for being with us here in Frankfurt. For now, we enjoy the rest of the evening. And if you're watching online, go get yourself a good drink. Thank you so much. And this is me, Arvind, signing off till the next edition. Thank you so much.
Discover Next, the studio for facades and design. Next is the platform for innovation in the field of building envelopes, for inspiration, information, and communication. Initiated by Vicona, with leading industry experts as Next partners. Next is a unique concept which is constantly evolving and bringing the future of cities to life.